So this is lesson 7.6. I don't know if we'll have an A and a B and a C or just an A, but we'll start out with just 7.6, and this is intermediate algebra, systems of linear equations in three variables. Okay, so far we have done systems of equations in two variables. So what we've done in the past, in the last lesson in fact, is something like 3x plus y equals 4. And 4x plus y equals 5. And when you were given that, you were given two equations and two variables. You have to have the same number of equations as you do variables. If I just had 3x plus 5 equals 6, I can solve that. I have one variable and one equation. It can be solved. I have in this one up here, I have two equations, two variables, so it can be solved. Now what we've done in the past is we've done either elimination or substitution in order to solve for x and y. Okay, in this lesson we're doing things a little bit different. We've got three variables. So for example, we have x plus y plus z equals 6, and my z's always have a line through them so they don't look like 2's. 2x minus y plus z equals 3. X plus 2y minus 3z equals negative 4. Alright, so I have three equations and three variables because I cannot solve if I have more equations than variables or more variables than equations. Alright, I guess it's more variables than equations. So, in order to solve a system that has three different variables in x, y, and z, we can only do two equations at a time. When you're adding numbers, you can only add two numbers at a time. When you subtract two numbers at a time. When you multiply 3 times 4 times 5, you don't multiply 3 times 4 times 5 all at once. You multiply 3 times 4 is 12, times 5 is 60. When you add 6 plus 3 plus 2, you don't add those all at once. You go 6 plus 3 is 9, plus 2 is 11. So when you do any of the four operations, addition, subtraction, multiplication, or division, you do everything two at a time. It's the same way with these problems up here. This system has three equations, but we can only do two at a time. And that's what we're going to do in this lesson, is just teach you how to do two at a time. So in order to do this, we're going to pick two equations and get rid of one of the variables. Okay, so that's what we're going to do here. So in this particular one, let's look at the first two equations, and the reason I picked that is because I can add these two just like we do elimination. I'm going to add these, but notice I have a plus y and a minus y, so when I add these, my y is going to go away. So remember what I said the rule is? When you want to find if you want to solve a linear equation in three variables, you take two of the equations and get rid of one of the variables, so that you get rid of the easiest one. So I'm going to put those two together. In fact, let's just add them over here to the left. X plus 2x is 3x. These two added make the y go away, and we're left with 2z equals 9. Alright, so now we got rid of the y variable. Good. Now what we're going to do is we're going to look at two more of these equations. It doesn't matter which two, it just can't be the same ones. Well, I guess it could. So you can just pick any two equations here and get rid of the y again, so that when we put it under this one, we don't have any y to look at. So let's look at this one here. I'm going to go ahead and do these two right here. So 2x minus y plus z equals 3. X plus 2y minus 3z equals negative 4. Alright, so I'm trying to get rid of the y's. In order to do that, I'm going to have to multiply this top one by negative 2, or I'm sorry, just 2. so that when I multiply it by this, I get a negative 2y. Whoops. Alright, let's try this again. We're going to get 4x minus 2y plus 2z equals 6. In the bottom, we didn't do anything to. But see what happened? My middle term, my y's are going to cancel here when I add them. And those go away. Okay, so now I have an x and a z there, and I have an x and a z there. So let's put this 5x minus z up here. Okay, that is really the only thing that we did different in this lesson than what we've done in the past, because now look what I've got. 2 equations, 2 variables. I know how to do that. I'm going to multiply this one by a 2 so that I can get a negative 2 there so that it cancels. So let's go ahead and write the first one as is. Now I'm going to add. Those go away. And x equals 1. Alright, so I found one of the variables. X equals 1. Alright, that's the hard part. The rest of it is just plugging in order to find my x, or my y and my z here. So what do I do with that x equals 1? Well, I look in all of the equations that I have written here, and I look for one that has just 2 variables, and one of those variables is an x. So I'm looking, I've got one right here that's just got an x. I have one right here that just has an x. So let's take this one. This one looks the easiest, and I'm going to plug that x in. And remember, if we have a negative z, we just change it to positive by changing the sign of everything, and we have z equals 3. Now I have 2 answers. I've got x is 1 and z is 3. Now I'm going to go back to one of the original problems to find y. Okay, so I'm going to put my 1 in for x, my 3 in for z, and I'm going to solve for y there. Alright, so I'm going to rewrite x plus y plus z equals 6. And I'm going to get this all out of the way here. Okay, and what did I say? X is 1. I don't know y, and z is 3. So 4 plus y equals 6. Y then equals 2. Alright, so what did I find? I found my x is 1, my y is 2, and my z is 3. And I can go ahead and write my answer just like that. And that is called an ordered triple. You just found the x, y, and z of the the system using 3 variables. And that's it. Alright, let's jump to example number 2 and see how we do here. Let's see if we can do it in this video without having to start another one. If I can get rid of, oh my goodness, this stuff. Okay, so example 2. 2x plus y, oops, minus z equals 3. And 2x minus 3y plus z equals 1. Okay, so this is January, gosh, what is it? January 2nd, 2017. I'm at a campground in Florida. And the temperature is about 73 here at 9:30 in the morning. People are just kind of getting up and around. I'm sure you all wanted to hear that. It is cloudy though, so that's kind of sad. But I am kind of sweaty, a little bit warm for an Alaskan. Okay, so sorry for that nonsense. All right, so let's look at these three equations. All right, so I need to get rid of one of the variables. So again, I look and see which variables are going to be easiest to get rid of. Well, the z's are going to be easiest to get rid of because there's no number in front of them. So I don't have to find a common number like this one here. I've got a 2 and a 3 here. I'd have to make them 6's. This one and this one I could do, but I'd have to make all these negatives opposite, so that would be a negative. The first two are already done. So I'm just going to write them over here as 2x plus y minus z equals 3. And what did they say the bottom one? 2x minus 3y. I'm going to add those up. Okay, so now I'm going to circle this in green or block it out in green. I have one equation with two variables. I got rid of the z. Now I'm going to look at two more equations and see if I can get rid of the z. I'm going to look at these two because those are both going to be cancelable. So 2x plus y minus z equals 3. And let's take the second one. 5x plus 5y equals 9. I have x and y's there. I have x and y's there. So now I can take my one right above and this one here, and I can add those after I find a number that I can eliminate. Alright, so what do? I need to either get rid of the y's or get rid of the x's. Probably the y's would be easiest because 2 and 5 are smaller numbers than 4 and 5. 4 is bigger than 2, so I work with smaller numbers that way, but the common multiple is going to be 10. So I'm going to multiply this by 5 to make that a 10, and I'm going to multiply this by 2 to make that a 10. Alright, so let's go ahead and distribute that 5. 20x minus 10y equals 20. And the bottom is going to be 10x plus 10y equals 18. So I have 30x, these go away, equals 38. And x equals 38 over 30, which is equal to 19 over 15. That is not pretty. 19 over 15. Alright, so that's our x value. So, let's see, I'm going to put x equals 19 over 15 up here, just so it's there. And I can continue on, and then I'm going to look for a y, and then I'm going to look for a z. Probably all going to be fractions, though, the way it looks. And we will finish this in the next video, since I'm almost at 15 minutes.